Why does the ring want to hit my finger?
Flemdog Science with me, Caleb Fleming. Subscribe, like, comment, and hit that bell.
What's up, science lovers? Welcome to Flemdog Science, where we explore things that make us go, whoa. Today we're going to be looking at one experiment only. If you missed all these sweet experiments and how they interact with a fun little balloon, you need to check that video out. I'll put the link in the description. This is our one experiment. Today we're going to use these rings to explain what I think is going on with induction when we bring this balloon close after rubbing it. For a little background, let's first look at this PHET simulation. If we look at our balloon here, our balloon is neutral. It has equal amounts of protons and electrons. And then if we bring that balloon close to a t-shirt or some surface and rub it on it, it'll pull the electrons right off. And then if we bring it close to the wall, the electrons in the balloon will repel the electrons in the wall, but the protons stay stationary. If we get even more electrons, it'll repel even more electrons in the wall. And if we let go of the balloon, it would even stick to the wall because the protons on the surface stay stuck to those electrons in the balloon. And it'll also stick to that t-shirt if we put the negative electrons next to the positive t-shirt. Now that we have an idea of how electrons move, let's watch what happens with our rings. Let's simplify our system by only having one ring at first. If the balloon is brought close, nothing happens. The balloon is not rubbed yet. What happens once I rub the balloon? Just wait. As I'm rubbing here, what's the balloon picking up? Right? So what's that make the charge of the balloon? So we got a negatively charged balloon with extra electrons. It jumped towards it and then bounced away. And did you hear that shock? What's that shock mean? What's moving? What's causing that shock? That is the movement, the discharge of electrons. So watch what happens when we bring the balloon near again. It's repelling it. You see that? It's repelling the aluminum ring. That's so cool. We have to figure out what in the world is going on. Let's see that one more time. The aluminum ring did not even touch the balloon, and then we heard the shock, and then it shot away. And now watch. It repels. It's repelling it. Just the cool. This is the single coolest demo, man. Let's watch what happens with two rings now. Okay, look at our rings. They're not wanting to go together now. It bounced off the balloon, got close to the other ring, and now the two rings don't want to go together. What happens when we bring the balloon close? It repels both of them. Isn't that really cool? So let's explain that in our diagram now. We'll create a model, the best that I can of this situation, and your job is to let me know things that I miss or leave out, or maybe ideas that I didn't incorporate that we really need to. Protons for us in this diagram are going to be represented by these red pluses, and electrons will be represented by these green negatives. If we draw our balloon, and then we show that the balloon has protons, we'll just draw 3 of them here to simplify, and electrons, we'll draw 3 to show that there's equal amounts. The balloon starts off neutral, but then we rub the balloon, and rubbing the balloon added extra electrons, like we showed in our simulation, which made the balloon negative. It has all these extra negative charges from electrons. Then, if we draw our foil starts out neutral. It has equal amounts of protons and electrons. We see 4 protons and 4 electrons. So it's neutral, protons equal electrons. So our balloon has more electrons than protons, which makes it negative, and then we bring the two of them close together. When we draw our next balloon and show that we have our protons and electrons in this electron side of the balloon that has the extra electrons on the right there, it's negative. And then we draw our foil. Our foil has equal amounts of protons and electrons. It's neutral. What happens when we bring that balloon close to the foil? Well, foil is conductive. That means electrons move really easily through it. So the negative electrons are always going to be repelling each other. So if we bring a balloon that's negative close to the foil, the negative electrons in the foil that are close to that negative balloon are going to get repelled to the opposite side of the foil. And we see those electrons move to the right. Electrons in the balloon are going to repel the electrons in the foil. So what does that do? That's going to leave the protons that are on the left side of the foil. And so protons are positive. So the left side of the foil, it's kind of like it's positive. We call that partially positive if we want to introduce that term. And the right side is kind of negative because now the right side has 4 electrons and 2 protons. So there's more electrons than protons, which makes it kind of negative. So the right side is partially negative. Overall, though, the key thing that we want to notice is that it's still neutral. That means that it has equal amounts of protons and electrons. Let's draw our next balloon. It has our protons and electrons and extra electrons on there from being rubbed. And our foil has its protons and electrons, with the electrons moved over towards the right side, making the left side with the remaining protons sort of positive, partially positive, and the right side with the extra electrons sort of negative, partially negative. And what did we hear and see if the lights were a little bit darker? Shock. What happened when we shocked that foil? The electrons moved over to that partially positive side to be near those protons. So the electrons transferred from the balloon onto the foil. Now, what got cut off is both the balloons and the foil are now negative. Our balloon then has its electrons and 2 of them left, so we just show 4 on the outside of the balloon now, but still negative. The foil has its electrons, but it gained 2 extra electrons. So both of these items now are negative. The balloon is negative and the foil is negative. And what do negative things do to each other? They repel each other. So if we draw our next one, we see our 2 foil rings. And if we bring the foil ring A, which is now negative, close to foil ring B, which is neutral, what's going to happen? Well, both of these are still conductive and negatives still repel negatives. So the negative electrons in A, those extra ones that are making it negative, are going to repel the electrons in B and push them away. What does that do to B now? It's just like what we just saw. B now is going to have some extra negatives on the far right. That makes that side partially negative, and an exposed proton here, which is going to make the left side partially positive. Now we can have some electrons move from A into B. So A lost an electron and B gained an electron. But A still has more electrons than protons. In our diagram, it has 1 more electron than protons. And B now is going to have 1 more electron than protons. So it's negative also. Let me correct my arrows. A and B now both have the 4 original electrons plus the extra electrons, which make them negative. Since they're both negative, they're repelling each other and moving away from each other. So that is why we see them not wanting to touch. And when we brought the balloon back close to them, what did we see happen? How can we verify that they were actually negative? Well, the balloon we know is negative because it pulled away those electrons from the surface, and we'll say it still has those 4 extras, making it negative. So if the balloon is negative, what would happen if those foils happen to be positive? They would attract. If they were negative, they would repel. So what did we see happen? We saw those foil rings repel from the balloon. That suggests to us that the foil rings are negative. They have extra electrons. So they are repelling from the balloon as well as repelling from each other.
If you like that, consider subscribing and come back again. We'll do another cool experiment soon. Have a great day.